welcome in this section, and we are going to talk about IPsec. This is a very testable topic in your CISSP exam, and definitely you will at least get 1 or 2 questions in your exam from this section. But before I dive into IPsec, let me also talk about where this entire piece is actually fitting into the big picture, right? So especially, let's say during COVID, all the people are moving to their home. You all might be working in a hybrid model right now, right? Many of you might be working from home, and at that time, let's say you are part of the administration team, or you have something critical which has to be done. You have to get connected with your network. So in that cases, we use something called as a VPN, right? So this all comes under something called as remote connectivity. Remote connectivity. And when we talk about remote connectivity, let's understand this more holistically. People feel remote connectivity is always VPN. That's not the case. So remote connectivity can happen in different ways. Number one, how it can happen? When you access a website. Don't you think that time as well you are doing remote connectivity? The remote server is remote, and then you are connecting to it through some interface. You might be using a browser to connect to a remote applications, right? So in that kind of thing, what you are actually doing, you have a application called as your browser or maybe some other application, and then you are using it to connect with another application. Mostly examples might be websites, okay? And in that cases, we need to make sure that whatever transaction is happening between you and the server is always secure. So what we do, we use some secure protocols which can make sure that the data in transit, when the data is traveling from point A to point B, is keeping secure. And how do we do that? We simply use SSL TLS. Specifically, you should be using TLS 1.2 or higher. So that will make sure that there is an encrypted tunnel which has been created between your application and the remote application. That's all. So that's one way of connecting. The another remote access you might have also witnessed is when you are connecting a particular system to another system. Let's say you have created a Azure virtual machine and you want to connect from your PC to the Azure environment to your virtual machine. You can use it in 2 different ways. You can go through graphical user interface. You can also use RDP and such kind of protocols which can help you to provide you graphical user interface, and then you can connect, log in, and you can see the desktop and everything. There are a lot many graphical user interfaces, for example, TeamViewer and RDP, and there are so many, right? You might have noticed that. On the other side, you can also connect through character user interface. That is means through the command prompt. You take a remote shell. You try to get into the shell mode to get access to the remote system. And for that, we might be using sometimes telnet, which is anyways not recommended to be used for sure, because it doesn't encrypt your credentials. So the best way to connect is SSL and SSL SSH 2.0, secure cell version 2.0, which is the latest protocol. It makes use of your PKI environment. It has some kind of public key, private key concept, and it will be completely using asymmetric cryptography for doing the key negotiation. And then once the key is established, symmetric key is established, session key is established on both the side, then the entire traffic will be encrypted using symmetric key. The same way I have explained you, like the websites and all. So that's another way of connecting to it. You might also might be sometimes using putty and all of these kind of stuff. So that's another example just to relate. Then another way of connecting is when you are connecting a system to a network. When you are connecting a system to a network, now it might be a end user connecting to a network, or it might also be a site-to-site connectivity as well, right? Your internal company site-to-site connectivity. And this is normally achieved by using something called as VPN, virtual private network. We call it as virtual because this entire thing is virtual. There is nothing, no separate pipelines or wires which are kind of spread. It is private. It is private because you are going to connect with your network which is on a private IP, and once you get connected, then your IP also become private. So you become as if you are sitting locally in your office, even though that's not there. That's not the case. You are physically maybe very very distant away, but you are trying to connect it even through a internet which is kind of considered insecure. You are able to still connect to it. So that's the concept of VPN. So always keep in mind, remote connectivity is just not about VPN. It's all this. So always think from a bigger mindset. Now, when we do that, let's talk about VPN, right? A particular VPN, virtual private network, is what? A virtual private network is a combination of two things. Number one is called as tunneling. Okay, number one is called as tunneling, and the second thing is called as encryption. Now, a VPN not necessarily all the time will always be encrypted. It can only be a tunneling as well. There are some specific protocols, for example, GRE, generic routing encapsulation, is one of a fantastic protocol, open source protocol, which is used for encapsulating. So what is encapsulating? And into network, I can say you with guarantee, encapsulation is something you must know. For example, you have something and it has to, let's say you have a car and you need to make it travel on a railway track. Can you make a car travel on a railway track? Not possible. So what you will do, you will actually load this entire car on a railway this thing, right? And then you transport, simple as that. So the same thing happens in networking as well. Even routers, when they are routing your information, or even switches, sometimes when they are routing your information, they are nothing but actually using encapsulation to pack one packet within another packet with its own source and destination addresses and all of it. So the same thing happens in case of tunneling. At the same time, you can have tunneling, and just tunneling something is not secure. It's like you have a big mountain and you have created a tunnel out of it. Now people are going, your vehicles are going, but there is no safety. Even though there is some level of safety, but it's not completely secure. So we need to also make sure that these packets itself, which are actually traveling, they are also encrypted. So a secure VPN is only that VPN where we are securing and making sure the data part, at least if not everything, at least the data part is encrypted for sure. So that's called as a VPN. Okay. Now this VPN, whenever we are doing this entire tunneling, it can be done in two modes. VPN can be done in two modes. Number one is called as transport mode, and another one is called as tunnel mode, right? Now what's the basic difference between a tunnel mode and a transport mode? Let's say I have a packet, and this packet will always have, as you know, it will always have a header, and it will also have a payload. Payload means data itself, because end of the day the entire packet is traveling because you need to transfer some data. So this is the data part. Okay. Now when we use transport mode, what we do actually, the original header of the packet is kept intact. Please make note, the original header in a transport mode is kept intact. Let's say you are using authentication header or ESP, which I am going to talk about in just a while. What will happen is your header will be here, and then come your authentication header or whatever you want to use, and then your payload and maybe a trailer as well. But the data is actually driven only by using this header, and this header is kept intact. So you are not changing the driver in the car. That's very important. When the same thing we do in tunnel mode, actually you change the driver. So for example, this is your header and this is your payload, then you bring your own driver, you bring your own header. So that's the base difference between a tunnel mode and a transport mode. Okay, these VPN can also be implemented based on your infrastructure and the kind of posting and all of those things which you support. The VPN can also be divided, or you can say implementation can be divided into two parts. One is you can say tunnel mode, and another one is called as split tunnel. Now what is completely tunnel mode? For example, this is your laptop at home and you are working from home, and then you are connecting with your company infrastructure, right? All of it. What will happen is your entire traffic, let's say you also want to go to Google, right? Everything will first go to your VPN concentrator, which is placed inside your company, which is part of your company infrastructure. That is where all the rules will be applied. If you are supposed to go on Google, then only you can go on Google, otherwise it will not let you do that. The entire VPN is taking everything, all network connectivity first go to your company, and then from your company, if there is a traffic for outside, it will route it accordingly, and for your company traffic, that will go inside your company. So that is called as a purely tunnel mode. The another mode which we have is called a split tunnel. So in split tunnel, because in this kind of model, the infrastructure load is always heavy. If your company do not have that much infrastructure bandwidth and all those kind of things to support, then this can be a costly affair. But at the same time, from a security perspective, this is always recommended. In some companies, I have also seen they implement split tunnel, and in that what happens is, let's say this is your laptop and you are going to connect with your laptop, and let's say your corporate data, your domain specific corporate data only goes to your company network. If you are using anything outside your domain, anything you are using outside your company, let's say you want to go to Google, then you will be allowed to do that from your laptop itself. So in this case, the load on the infrastructure will be less, but at the same time, security will also be less. Why security will be less? Because nowadays this particular guy might download something which might also have impact on your files, and the infection may also go to your company network as well. So that's what it is. Highly recommended whenever we are implementing a entire VPN. It is always recommended that usually I am telling you the normal architecture. Your company may have little different, but on a generic level, when it comes to a company level, what we do, we actually have something. We all know we have DMZ, and in that DMZ we have something called as a VPN concentrator. Sometimes people configure their router in that way to act as a VPN concentrator.
Manoj sir.
Yes, go ahead.
Sir, I just want to know one thing. Just could you please go back to the last slide?
Please.
Yes. Okay. A company is configured their VPN in tunnel mode. Okay. What happened if the user is not connected to the VPN and do whatever they want?
Yeah, then they can do. I'm telling only when the VPN connection is live. That time, entire traffic has to be routed to your VPN concentrator, and your VPN concentrator will decide based on your prefetch policies and everything. Either the traffic has to be allowed or not allowed.
So for this kind of situation, we definitely implement the EDRs Okay. And I think CASB or the DLPs, right?
Yeah, those are additional controls. There is no relaxation to that. We are just talking about remote connectivity and the models and the
Yes.
kind of things you should have complete clarity on.
Yes. That's
Yeah,
correct, sir.
yeah.
So, but in split model, if we implement the same controls and we are getting the benefit of reduce the bandwidth of the user. So, as a business
Yeah,
perspective, so which is this the better way? I'm not talking about the
sir,
security perspective
see,
because
there is always a fine balance between comfort, costing, and security as well. So you have to
yeah,
decide based on your organization culture, your requirement, your compliance requirement, maybe for a specific project which is very, very secure, which is like compliance driven completely. You might not like to go for a split, you might like to go for tunnel mode, or maybe for rest of the projects and rest of the people, you might go with the split mode. This is completely
okay.
up to you to decide based on your company requirement. Yeah.
Understood.
So this is completely your business driven and security driven. You have to find the best balance between them based on your company requirement. Okay.
Okay.
Fantastic. Let's go to the next part. So what I was actually covering is I was trying to tell you how this actually things are implemented on ground, how this entire VPN infrastructure actually works. So for example, there is a laptop who want to connect through VPN. Usually, even though VPN can also be connected through some configuration part, and you can push in some kind of GPO on your system to configure that VPN everything. But usually, what I have seen, people mostly use some kind of endpoint softwares which will actually connect you to the company infrastructure, and based on your selection with some kind of user ID, those things also can be included with MFA and all of it. You can connect with the VPN concentrator. So see, one thing is very important. Anybody who's going to connect with your internal network, you cannot let them come just like that. They had to be some kind of vetting, right? So those people will land up on the VPN concentrator, or you can say authentication server, and in the backend this is then connected with your, you can say, let's say, radius server. Okay, we don't expose the radius server onto DMZ, or we don't ever expose our active directory into the DMZ, because they are very, very critical assets. We are not gonna expand any of those things outside. So request from VPN concentrator, which is actually concentrating all the VPN request, and then it will go to your radius server. Now on radius server, you can have a local database for authenticating user. You can also connect it with a database as well, or you can also connect it with your existing active directory as well. So radius server is a kind of server which works on AAA, right? In access control, authentication, authorization, and accounting are three major steps. So all those three things are done by the radius server. It will authenticate from the active directory, and then once you are authenticated, then it will connect you with the DHCP server, and DHCP server from the required pool for the VPN. Might be there is a separate subnet only assigned for VPN. That's the best way to do that. We keep it always segregated from your rest of the production network. It will then actually assign you an IP. Your computer will take that IP. So if your network is 192.168.1.x, you will also be on 192.168.1.xyz, whatever IP you have. And then you, even though you are sitting remotely, you are on internet, you are on your home network and traveling through internet, you actually are just local to your network. So there is a separate VLAN which you are now connected. Most of the time when we connect, let's say you are a system admin, you are going to after the DSCP is assigned to you. Sometimes we also have a captive portal as well for taking extra steps. Otherwise you can then go to a jump server, and jump server are the intermediate server on which you are going to land up you are going to authorize yourself. Again, you have to go through authentication process, and then from this jump server you can take a remote session to any of the server you want to manage. So that's a very typical structure for a VPN connectivity what we have. Okay, so I hope you now understand whatever we have discussed. Just a quick recap of the entire stuff. We started our discussion. Actually, the main topic has not yet started. We are going to talk about IPsec. I want to give you a holistic picture. So I told you what is remote connectivity. Just don't keep yourself screwed only to VPN. It's a way more. We then spoke about tunneling and the encryption, the core difference between these two things. Sometimes exam checks that as well. VPN can be connected in transport mode and tunnel mode. You understood that difference. Then I have spoken about VPN implementation part. You can go with tunnel implementation, or you can go with split tunnel based on your business requirement. And then I gave you a practical scenario how in company's environment we implement VPN. Now we are going to actually come on to our main topic, and the main topic here is IPsec. Okay, IP security, right? IP security is the perfect way and the de facto method nowadays which is used for connecting to VPN. By default, IP version 4 does not support IPsec. IP version 6 support IPsec by default. So we have to use some different type of protocols and other things to start with it. To understand IPsec, very important that we understand few major terms here. Number one is called as security parameter, right? What are security parameters? Let's say a remote connection A want to connect with a VPN. Then there has to be some kind of authentication happening. There has to be exchange of parameters, that this is the cryptography which I support. I support this particular protocol, all of it. For negotiation, there are certain SP security parameters which are required in the entire context. So that's called as security parameter. Number two, when a computer A want to connect with this VPN, there has to be some kind of authentication and negotiation, right? Obviously. So for that purpose, there is a protocol called as IKE, which stands for Internet Key Exchange, right? And this particular protocol is responsible for the entire negotiation between two computers and authentication as well. This actually works in two phases, phase 1 and phase 2. In phase 1, there will be a pre-authentication kind of activity which will happen, where the two computers will negotiate, okay, this is what you support, this is what I support, and लड़के की शादी हो सकती है क्या, वो like हमारे वो कुंडली मिल रही है क्या, all those kind of stuff between two computer will happen. That's phase number 1. When the phase number 1 is done, when the two computers are ready, then the actual game happens in the phase number 2, where the two computers actually negotiate, and then once they are negotiate, the VPN connection is established. Okay, so that's how this happens. Most of the time it is a certificate based thing. If you are going to implement certificate based authentication, that's always the best. So certificate based means your public key will come, and something which I have explained to you, right? Some kind of digital certificate will come to you. You will generate a session key and then exchange to the other party. That will be used to actually encrypt the data and all of it. So I have already explained you guys. I think that is one part. So I understood what is IKE. IKE use some other protocols also in the entire scheme of thing, but you can think this guy as the manager who is entirely responsible for end-to-end. He is also using some important people out there like ISAC, MP, and such some other protocols. But they're all included in the IKE portion. The third important thing, which is very important to understand, is called as authentication header. Now this authentication header is one of the key component most of the time in VPN. Let's say you want to connect VPN within your company and you want to go faster. and those things. One important thing about authentication header is it provides you authentication, right? It also provides you integrity as well. Okay, authentication, how authentication is provided to you based on message authentication code, MAC. And I think in domain 3 I have already explained you guys how does that entire thing work, right? So what will happen is this is your header, and this is your authentication header which will come in between, and then will be your payload. And on your original header itself you are going to use it. So that's your authentication header. This kind of thing is good within your company because it provides you authentication and integrity, but there is no confidentiality into that. If you need confidentiality as well, then we use another protocol which is called as ESP, Encapsulated Security Payload. Encapsulated means it is already encapsulated most of the time, even though ISP can also be used in transport mode, and we can also use it in tunnel mode as well, right? But ESP, the main important thing is it not only provides you with these two services which authentication header provides it, but it will also provide you confidentiality. Okay, that's kind of very, very important. So till now we have understood about 1, 2, then 3, 4. Number 5th, when this entire IKE phase 2 happens, then every VPN connection is given a unique number. It is given a unique index number that is also called as SPI, Security Parameter Index. This is the identification. This is a particular number, right, which is used for this entire connection between the two parties. Okay, now this can happen on multiple layer. It can also happen on application layer as well. Whenever we want to use VPN over TLS, we can also use VPN over TLS as well. So we are leveraging TLS, the entire web thing, into this entire VPN as well. Sometimes people only connect from application which is locally installed in your system to connect with your VPN concentrator and all of it, and then based on that you might use some kind of multi-factor authentication as well. So how does this entire thing actually will happen? Let's say there is a VPN client, and this VPN client want to connect with the VPN server. Obviously I have told you 4-way handshake. Most of the time it is certificate based. So your VPN client is going to reach out, establish a HTTP session, and send the post request to your VPN server. Your VPN server will provide back the digital certificate plus server hello. This is client hello, this is server hello. And then once the digital certificate comes to your client, the client is going to validate the digital certificate by validating the digital signature of the CA, right? Once that is done, what will happen? The client will establish the session key and will encrypt it by using the public key which is available in the digital certificate, and then it will send across to the VPN server. Now both the party will have session key, and here also we have session key. Then rest of the communication can happen between these two parties based on you can say session key encryption, symmetric key encryption. So that's how entire VPN actually takes place, right? So nowadays if you have a situation where you want to implement a VPN, VPN might require you to install some kind of software and all. So there are some open source or open VPN also available which you can leverage, which is also quite secure at the same time. But make sure that you are encrypting data when you are having a VPN, if you are any time connecting on the internet. That's very, very important. So that's the story, guys. That's how IPsec has been covered. So not only IPsec, I have covered the entire remote access to you I have tried my best to give you the best clarity on that. Okay, so in the next thing we are going to talk about maybe some other topic you want me to discuss today. That's countering keywords in the CISSP exam, TLS, all of it. So that's the next topic.